aspirants, so your midterm exams are ahead and we have already completed the one-shot lectures of the chapter Haloalkanes and Haloarenes. So in today's class, we are going to discuss the most important questions from this chapter, including the MCQs, 2 markers as well as 5 marker questions. Okay, so let's get started and solve these questions. So first of all, you can see according to the question pattern or blueprint, I can say you will get 2 questions of 1 marker, 1 2 marker questions and 1 long answer 5 marker question. Okay, so let's see what we have in 1 marker question. So this is the questions that was there in sample question paper 1 of 2025. Okay, so you can see enantiomers are non-superimposable mirror images on each other. A racemic mixture shows zeros optical rotation. So in my one-shot video, I have explained this concept in detail and I have told you that yes, enantiomers are non-superimposable images of each other, and yes, a racemic mixture shows zero optical rotation. The reason here being, in racemic mixture there is 50% of plus isomer and 50% of minus isomer, right? So that is why both the statements are correct. Option number A is the correct answer. Next, the chemical name of phosgene is, so if you see the structure of phosgene is like this. Okay, so it is what? It is actually, is it chromyl chloride? No, there is no chromium, there is no phosphorus, there is no phenyl. Yes, it is carbonyl, this is carbonyl and then chloride. Okay. Next, okay, so students, before moving to the next slide, here something very important I have for you to announce. So you know that KCET, KCET and PU2 exams are the 3 more important exams that are coming ahead, right? So to help you with your preparation, we have started a new crash course called as KC 90. Okay, so you can see here 90-day crash course will be there, 2 exams, 1 goal, top 1000 rank. So if you take this crash course, we will definitely make sure that you will be under top 1000 rank. So these are offline classes across 8 Diksha campuses. Okay, that's the first thing. Second, there will be entire syllabus coverage for PU2 plus KCET plus KCET, and the third one will be, there will be 40 plus part test and full length test based on KCET and KCET pattern. Apart from that, PU2 test series will also be available, although that is optional. You can opt for it, you can not opt, you can you may choose or may not choose it, but yes, that is also there. Personal guidance will be given, offline classes will be there, experienced Diksha faculties will be teaching you. Okay, and the classes will be 3 days a week, that is Friday, Saturday and Sunday. So for more details, you can click on the link given below. There will be a link for that. So you can click on the link and you can visit the page, and if you are interested, do book the seat. And this is something which is a one-time investment that you can do for your career, for your future goals, right? So please do check out, the link is there in the description section, or you can call on this particular number to get more details about the classes. Okay, now let's see the second sample question paper of 2025 1 marker. 1,2-dichloroethane is an example of 1,2-dichloroethane. So these are vicinal dihalides, so it is alkyline dihalides. Okay, let's see next question. That's a match the following question. So chloramphenicol. Okay, so chloramphenicol is actually used, so first let's see thyroxine. We know that it is used for goiter, right? 4 will be D, so I can eliminate these 2 options. Next you have halothane is used as an anesthetic, right? So 3 will be B. So I have this one, 3B. So I can eliminate this one. Next we have chloramphenicol is used for typhoid and chloroquine is used for malaria. So 1 will be C, 2 will be A. So that is option number B here. Okay, chloramphenicol, please remember typhoid. Here it is for, here it is for, you can relate that. Chloroquine is used for malaria. Okay. Next we have sample question paper 3. There was 1 MCQ and 1 FIB in this one. So let's see that. So the 4 haloalkane compounds represented by letters M, N, O, P. Okay, you have M, N, O, P. Having the boiling points are 24. This is 24.2 degrees Celsius. Next is 38 degrees Celsius. And next we have 3.56 degrees Celsius, and we have 101.6 degrees Celsius. Among the 4 compounds, N is most likely to be N, right? N is this one. You can see these are the compounds that is given to us is CH3 Cl, CH3 Br, C2H5Br and C3H7I. Now if you remember, if mass increases, right, boiling point will also increase. So here I can see that the highest mass is for this one, C3H7I. So the highest boiling point is this one. So definitely P is what? C3H7I. Okay. Next we have C2H5Br. Okay, this is the second highest mass. So C2H5Br will be this one, then N will be C2H5Br. Okay, so that has to be option number C here. Clear? Now let's move to question bank. Some questions are there. So chlorine containing antibiotic produced by microorganisms which is very effective for the treatment of typhoid. So just now we discussed it is chloramphenicol, option number A. Next we have the halogen that is used as anesthetic, that is halothane, option number D here. Next 1,2-dichloroethane, 1,1-dichloroethane. So if you have 1,1-dichloroethane, right? So this is what? This is ethylidene chloride. Okay, ethylidene chloride, that is option number A here. Next we have the total number of structural isomers possible for the compound having C5H11Br. So first of all, you can see you can have a straight chain of 5 carbon and then you can attach bromine here, that is one isomer. Next you can have 5 carbon chain, you can attach bromine here, right? Next also you can have 5 carbons like this and you can have bromine here. So we are getting 3. Okay, next we'll go for 4 carbon. So if I have a 4 carbon chain and I have a compound like this, so you can attach bromine here, that is one possibility. Next, if you have like this, whether you attach here or here, that is the same thing, right? Next you can attach here, that is the second possibility. Next we have like this and I can attach here, that is third possibility. And then there is one more possibility with 4 carbon chain. So I have attached 1, 2, 3 and I can attach 4 here, right? So I got 1, 2, 3, 4, 5, 6 and 7. 7 I have got, right? So already the answer should be, now if I have a carbon like this, 5 carbon, wherever you attach bromine, it will be the same thing. So total I'll get 8, option number C here. Okay. Next, which among the following has a chiral carbon? Chiral carbon means it should have 4 different groups attached to it. 2-chloropropane. If you see this one, 2-chloropropane. This side, both the sides I have methyl group. It is not different, so it is not the correct answer. 3-chloropentane. So if you see, this side also ethyl group, this side also ethyl group, not same. So that is also incorrect. Next we have 2-chlorobutane. 2-chlorobutane, yes, you can see this carbon. Okay, it has one side methyl group, one side ethyl group, one side chlorine, one side hydrogen. So 4 different groups are attached, so it is chiral, option number C here. Next, the alkyl compound having the largest CX bond. Largest CX bond will be in iodine because iodine molecule is very big, option number C here. The alkyl compound having the largest CX bond enthalpy. So if the bond is shorter, bond enthalpy will be more. So CH3F has the highest, shortest bond length, so strongest or highest bond enthalpy. Next we have the alkyl compound having the least dipole moment. So least dipole moment, we know iodine is least electronegative, so it has the least dipole moment. Next, the best reagent used to produce pure alkyl halides from alcohols, I have discussed, it is SOCl2 because it produces gaseous byproducts. Next, aryl halide cannot be prepared from phenol because phenol is more reactive, no. Aryl halide is more reactive, no. The carbon oxygen bond in phenol has a partial double bond character, yes. So if you see, phenol is like this, okay, and you have OH. Right. So now if the if a suppose for example SOCl2 is there, so chlorine will come and replace here, but this oxygen here is involved in resonance and there is a partial double bond character, so that is why option number C here. Okay. Next we have the reaction that produces a single haloalkane in low yield is. So it produces single haloalkane in low yield, that is your free radical chlorination, it produces in the low yield. That is why we don't prefer this method. Next, vicinal dihalides are obtained from the reaction of. So if you see, if you take any alkene and you just add Br2 here, so what will happen? The bond will break and we will get Br here, right? So this is your what we call vicinal dihalides or alkanes, not alkanes, alkenes with Br2. So where do I have? No, not this one, alkene and Br2, option number B here. Next we have then example of vinyl halide. Vinyl halide means what? When you have this one, when the carbon or the halogen attached to sp2 carbon is there. Okay, halogen is directly attached to one sp2 carbon, that is called as vinyl halide. Now if you see cyclohex-1-ene, you have a compound like this. Okay, 1-chlorocyclohex-1-ene, that is the vinyl chloride, obviously because the carbon is attached to one sp2 hybridized carbon. So option number A is the correct answer. Next, sim-tribromobenzene. Sim-tribromobenzene means when you have a symmetrical molecule. If you have like this and like this. Okay, so this is 1,3,5-tribromobenzene, that is option number D here. Next, an example of allyl halide. So what is allyl halide? When you have like this, the carbon to which X is attached, that is attached to an sp2 carbon. So that is your allyl halide. So if you see chloroethene, that is vinyl halide. 2-chloropropene, that is also not there. 3-chloropropene. If I have like this is propene, this is 3-chloropropene. Yes, this is an allylic halide. So option number C here. Next, dry acetone is used in Finkelstein reaction because it's a volatile solvent. No. It contains ketone group. No. The Ri formed, NaCl and NaBr formed is precipitated and favors forward reaction. Ri formed is precipitated and favors forward reaction. So if you see here what happens, Rx in presence of NaI dry acetone, it gives you Ri plus NaX. Okay, so this NaX which is formed is actually precipitated and that helps in the forward reaction. So option number C is the correct answer. Next, metallic fluoride which is not used in, it is sodium fluoride because we don't want ionic compounds here. Next, statement wise question, iodination of benzene is reversible. Iodination of benzene requires the presence of an oxidizing agent to oxidize the Hi formed. Yes, that is correct. And what type of oxidizing agent we used? Generally nitric acid is used. So both the statements are correct, that is why option number A here. Next, select the correct match. Okay, so Finkelstein reaction in NaI is correct. Schwarz reaction COF2 is correct. Then you have Woods reaction Na dry ether is correct. Sandmeyer, okay, one second, incorrect match. Yes, for Sandmeyer reaction we have one second, COF2 have we used. So let's see the incorrect match. Schwarz reaction, yes, correct match. Finkelstein, yes. Here if you see, it is actually Cu2X2 is used, right? So that is why this is incorrect, this is also correct. So 3 only, option number C here. Next, a compound X with molecular formula C2H4. So you have a compound X with molecular formula C2H4, okay. Then it reacts with HBr to give a compound Y. So if it reacts with HBr, you will get CH3, CH2Br. Reacts with what? NaI and dry acetone. So if it reacts with NaI and dry acetone, so what will happen? This I will replaced here. So I will get CH3, CH2I. Okay. To give a compound Z. So this is the compound Z which is formed here. So what will be the product? C2H5I, that is option number A here. Next we will be, okay, so just a minute, we'll check the now Okay, now we will move to next section, that is 2-marker question. So you will get one 2-marker question in section B. So let's see what all questions were asked in the previous year. So sample question paper 1 of 2025, the question was very simple, Schwartz reaction with an example. So we know that Schwartz reaction is the present or the preparation of alkyl fluorides. So alkyl fluorides are synthesized by heating an alkyl chloride or bromide in presence of metallic fluorides like AgF, Hg2F2, COF2 or SbF3. The reaction is termed as Schwartz reaction, and here you can write the example. Very simple direct question. And in 2025 sample question paper 2, there was also a question, chlorobenzene cannot be prepared by reacting phenol with SOCl2. So give reason. So just let me set an example. So if you have ROH and you react with SOCl2, you will get RCl, right, plus SO2 plus HCl, and this is the most preferred method. But in the same case, if I have OH and I treat it with SOCl2, that is not going to give me chlorobenzene. Why is this reason, or what is the why is this reaction not possible? So the reaction is very simple, or the reason is very simple. What happens here, the oxygen is having in resonance, so this bond is having a partial double bond character and it is more stable, right? So that is why this reaction does not take place. So how do we write that? Yeah, so you can just write down here that the OH, the carbon oxygen bond in phenol, the carbon oxygen bond in phenol has a partial double bond character, has a partial double bond character which makes it difficult to break. Okay, just that much you need to write. Okay, that's enough for explaining this one. Next, sample question paper 3, the question was about Fittig reaction. So Fittig reaction, we know if you have two aryl halides in presence of dry Na sodium dry ether, you will get diphenyl, right? So aryl halides when treated with sodium in dry ether give compounds where two aryl groups are joined together. It is called as Fittig reaction, and example you can write down like this. Okay. Next, we will move to PU2 question bank 2-marker questions. So just a minute. So the question here is, give two differences between SN2 and SN1 reaction. Okay, so you can see the difference. I can show you. Just a minute. Yeah. Okay, so I hope it is visible now. The first one is, it is a unimolecular reaction. In SN2 it is a bimolecular reaction. Then in SN1 it follows first order kinetics, SN2 follows second order kinetics. Next, in mechanism of SN1 involves 2 steps, and in SN2 it involves a single step. Next, we have reaction rate depends on the concentration of substrate only, and here the reaction rate depends on the substrate as well as the nucleophile concentration. Then here we have carbocation is formed as an intermediate, no carbocation is formed here. There is a no partial bond formation with the carbon during the reaction, there is a partial bond formation in that case. Next, the nucleophile attacks the carbocation from both the sides. Here the nucleophile attacks only from the opposite side. Then here we get racemized product, here we get inverted product. It is favored by mild nucleophile, strong nucleophile. We need here protic solvents, here we need protic solvents. Then you have rearrangement of product can take place, there is no rearrangement possible here. So I have given you 11 points, you can just prepare any 2 to 3 points. Okay, moving to the next one. Why free radical halogenation of alkenes method is not advised for the preparation of haloalkanes. So this also I have discussed. The reason here is we get a lot of mixture of products which then becomes difficult to separate them. That is why this is not a preferred method. So free radical chlorination or bromination of alkenes gives a complex mixture of isomeric mono and polyhaloalkanes which is difficult to separate as pure compounds. So that is why the yield is very low. You can give an example and you can end the answer here. Next question we have, haloarenes cannot be prepared from phenol. So the similar question we have already discussed, it was there also previously. So you can see here The preparation of aryl halides from phenols is not possible because the carbon-oxygen bond in phenols has a partial double bond character and it is difficult to break them than a single bond. So just now I have discussed this one. Same question can be asked in a different way also. Now let's see next question. Classify the following into geminal and vicinal dihalides. So ethylene dichloride, this is the common name for vicinal dihalides. And methylene chloride actually, so this is an example of geminal chloride. Okay. Next you have to classify into allyl and vinyl halides. 3-chloropropene, this is definitely allyl one, and you have 1-chloroethene, this is vinyl. Next, question number 5, write the chemical reactions for the following synthesis. So if you have isopropyl chloride, okay, this is isopropyl chloride, and you want to prepare propene. So what is the reagent we need? Alcoholic KOH. Next we have 1-chloropropane, and then we have again propene here, same reagent is required, that is alcoholic KOH. Now write the product obtained when ethyl bromide reacts with the following. So if I have ethyl bromide, okay, and you have alcoholic KCN, so that will give me CN. And if you have AgNO2 like this, AgNO2, so that will also add NO2 group, or I'll get nitroalkane. Okay. Next we have what is Grignard reagent, and write its general formula. So organomagnesium halides. Organomagnesium halides are called as Grignard reagent, and what is its general formula? RMgX. You can see organomagnesium halides. Next question, what is the reaction involved in the preparation of benzene from aniline? So benzene to aniline, so first benzene is converted to benzene disonium chloride, and then benzene disonium chloride is converted to aniline. So there are 2 steps, 2 marks you can write down here. So from aniline, first we get benzene disonium chloride in presence of NaNO2HX, and then once we get benzene disonium chloride, you can use Cu2X2, that is your Saint-Mier reaction, to give you which one? Bromobenzene. So just replace here X with bromine. Okay. Next we have question number 9. All the chlorine is an electron withdrawing group, yet it is orthopara directing in electrophilic aromatic substitution reactions. Why? So if you see chlorine, okay, it is a group, it is a I can say its minus I effect is very strong, so it is electron withdrawing in nature, but at the same time it also has lone pairs. Okay, now when it has lone pairs, it donates electron. You can see the charge density increases at ortho and para position. So although it is electron withdrawing, whenever it donates the electron, it increases the electron density at ortho and para position. So that is why it is overall, it is a, I can say, ortho-para directing. Now this is a question from your in-text book, in-text question. So I have given the in-text answers only. You can see how beautifully explained. You can write down a similar answer in your exam also. So let's see. Chlorine withdraw. So let's just, okay, just a minute. Okay. So you can see here, let's read and understand this one. Yeah. Chlorine withdraws the electrons through inductive effect. That's what I told you. It has strong minus I effect, and releases the electrons to resonance. So there are 2 processes chlorine can do. It can withdraw the electron from minus I effect, at the same time it can donate the electron through plus R effect. Now though inductive effect destabilizes, through inductive effect chlorine destabilizes the intermediate carbocation formed during the electrophilic substitution reaction. So you can see that when this double bond attacks this E, we get an intermediate like this, and this one is pulling more electron from this one, so it is destabilizing this structure, right? Inductive effect destabilizes the intermediate carbocation that is formed. Now you can see here that when it happens this one, at the same time it also stabilizes this one through its plus R effect. The carbocation is stabilized through plus R effect. You can see here it donates electron. Then you can see here if the bond shifts here and here, if it is if the electrophile is attacked here also, then also there is stabilization through resonance. So what do we see here? Through resonance, the halogen tends to stabilize the carbocation, and the effect is more pronounced at ortho and para position. The inductive effect is stronger than resonance and causes the net electron withdrawal and thus causes the net deactivation. The resonance effect tends to oppose the inductive effect for the attack at ortho and para position and hence makes the deactivation less for ortho and para attack. Reactivity is thus controlled by the stronger inductive effect and orientation is controlled by resonating effect. So what does it say? Overall, haloarenes are less reactive towards electrophilic substitution reaction also because of its minus I effect. But even if the reaction is happening, then due to the resonance effect, the substitution will only take place at ortho and para position, as you can see in the resonating structures. Okay. Next, we have question number 10. Question number 10 is, which alkyl halide from the following pairs would you expect to react more rapidly by SN1 mechanism? You have CH3Br and this one. So this is a 3 degree, this is a 1 degree SN2 mechanism. So first one will react better. Next, here if I see question number 2, the structures are given like this. Let me draw it for you. So I have, okay, 3 CH3 is there, then you have C, then you have CH2 and then Br is there and then you have C2H5Br. Okay, again you can see here it is less sterically hindered, so this one will react faster and here this one will react faster by SN2 mechanism. Next, the question is to identify the reactant. So you know this is Na dry ether, so here the reactant must be CH3 whole 3 CBr. Okay, so if this is there and if it reacts with Na dry ether, you will have a replica of this one and then the product will form here. Next, we have BO plus O2 H nu gives COCl2 plus HCl. This B is what? CHCl3, chloroform. Okay, chloroform and oxygen in presence of H nu gives you COCl2 plus HCl. Now next question, you have to explain Sandmeyer reaction with an example. So Sandmeyer reaction we have already seen. Aniline reacts with dilute nitrous acid to form benzene disonium chloride, and this benzene disonium chloride can react with Cu2Cl2 or Cu2Br2. So you can write this one. Okay, to give aryl chloride or aryl bromide, this is called as Sandmeyer reaction. Now moving to the next question, with the help of a chemical reaction, show that the presence of electron withdrawing group fastens the nucleophilic substitution reaction. This we have seen. So if you add one NO2 group, the temperature downs. Then if you add 2 NO2 groups, the temperature further becomes low. And if you add 3 NO2 groups, then at warm temperature also the reaction can take place. So you can see here, without any NO2 group, the reaction takes place at 623 Kelvin. If you add one NO2 group, it takes place at 443 Kelvin. With 2 NO2 group at 368 Kelvin and with 3 NO2 group with warm water, the reaction can take place. Next, we will move to 5-marker question. So in this chapter, 5-marker question, there will be only 2 questions you can expect. One is your SN1 mechanism and the another is your SN2 mechanism. These 2 questions will be asked in like SN1 itself. The 5-marker question in the form of will be 2 plus 3 or 3 plus 2. Okay, so if SN1 it is a 3-marker question, SN2 is a 2-marker question. So definitely this one question will be there. With that, 2 reactions can be given, 2 definitions can be given, something like that can be asked, or here one SN2 will be given and then 3 fill in the blanks reactions can be given to you. That's what will be asked in the 5-marker question. So you can see here sample question paper 1 of 2025. Write the mechanism involved in the conversion of 2-bromo-2-methyl propane to 2-methyl propane 2-OL. Okay, so the conversion is asking from 2-bromo-2-methyl propane, 2-bromo-2-methyl propane to 2-methyl propane 2-OL. 2-methyl propane 2-OL, right? So this is there, Br is converted to OH group. Now since this is a, I can say a tertiary group, you can see it follows SN1 mechanism, and SN1 mechanism has 2 steps. So what is the step 1 here? So step 1 is what? The loss of bromine or formation of carbocation. So I'll just show you how you can write down. So you can see here, yeah. So this one is step 1, which is formation of carbocation. Okay, and this is a slow step. You can write down here slow. So this bromine leaves and there's a carbocation formed here. Then there is step 2, which is attack of nucleophile. Okay, so this OH minus now attacks here and we get this compound, and this is a fast process. Okay, so this one itself carries 3 marks. Next, you can see what are enantiomers and name one physical properties which is different. So we have already discussed in one short video what is enantiomers, right? So enantiomers you can define as, enantiomers are non-superimposable mirror images. Okay, now what is that one property which is differs? The direction in which they rotate the plane polarized light. So suppose in enantiomers you denote one with D, another with small l, okay, or one with plus, another with minus. So if D is rotating in clockwise, L will rotate it in anti-clockwise direction. So the only property in which they differ is the direction of, or the direction in which, direction of rotation of plane polarized light. Okay, this is there. This can be completed. Fine. Now let's see next question. So this one in sample question paper 2 was there. So first of all, first part was about fill in the blanks. So you can see this itself carries 3 marks, and here there is a 2 marker question. So HBr follows Markovnikov's rule addition. So Br will be added. So if you see the negative part, Markovnikov's rule says that the negative part will go to the carbon having less number of hydrogen. This carbon, if you see, has 2 hydrogens, whereas this carbon has only 1 hydrogen directly attached. So Br will attack here. So what will be the product? CH3C, then you have here Br, and then here you have H, and then here you have CH3. Okay, next Na dry ether. So if you have 4 carbons, right, so 2 carbon 1 product, it will double, so it will be like this. This one will give you butane. Next you have NaOH 623 300 atm H plus. So now what will happen at such a high temperature? You will get this compound as OH. Cl is replaced with OH group. Okay, now explain Sedzeff rule with an example. So I'll just rewrite the answer. It went CH3, CH, here CH3, then you have CHBr, and then you have CH3. That is the first one. Here you have this one, and here you have this. Cl is replaced with OH. Now what does Sedzeff rule says that? In Sedzeff rule, the dehydrohallucination, the preferred product is that alkene which has the greater number of alkyl groups attached to the doubly bonded carbon atoms. So that is more substituted product is the more preferred product. So if you have this compound, for example 2-bromopentane, okay, if you take here also there is one beta hydrogen, here also there is a beta hydrogen. This H and Br, if it is abstracted, we'll get a product here. And if this H and this Br is abstracted, we'll get a product here. Now there should be more number of carbons attached to the doubly bonded carbon. Now you see, these are the double bonded carbons. Here you can see one side there is H and one side there is carbon. This side also you can see one bond is H, another bond is CH3. So we have 2 carbon groups attached to this doubly bonded carbons. But here if you see that this side there is 2 hydrogens and here there is only 1 carbon attached. So since this is more substituted, this is the major product according to Sedzeff rule, that is 81%. Okay, so this there. So next question, write any 3 differences between SN1 and SN2. So this was in sample question paper 3 2025. So already I have given you 11 difference points. You can write down that. Next, identify the product A and B in the given reaction. So if you see this one, this is your Sandmeyer reaction. So what will be A here? So A will be, we'll get benzene disonium chloride, okay, N2 plus and Cl minus, and then after that we have to use Cu2 Br2 to to get bromobenzene. Okay, yes, that's yeah. So now here I have some important things that you should focus from this chapter, so that you can revise it at the last moment. Some important definitions: what is retention, inversion, stereocenter, enantiomers and racemic mixtures. These definitions you must prepare. The name reactions complete list I have given, so please prepare the name reactions. So in every name reaction you just need to write the statement and one example, right? So I have given some certain questions: Wurtz reaction, Finkelstein reaction, Dow's process, Friedel-Crafts, Wurtz reaction, Fittig reaction, Wurtz-Fittig and Sandmeyer reaction. All these name reactions you must prepare. Next, mechanism, SN1 and SN2, both the mechanisms you should be knowing how to write. SN1 and SN2, okay, both of them mechanisms and examples, differences is important here. Okay, so yes students, that's all in this chapter, and I hope we have done most important questions. If you practice these many questions, definitely you can solve the 2 mark and 5 marker questions. You don't have to worry, just you need to practice these questions. Okay, so that's all in this video. I hope this video was helpful. If you still have any doubt, put down in the comment section. I will definitely address it. Thank you for watching. All the best and keep smiling. And yes, once again, the KC90 link is given in the description section. Please check it out, and that is going to be one of the biggest steps that you can take to secure top 1000 rank in KCET 2026 examination. All the best and bye-bye.